Okay, so that's where HarvestWater comes in. It's a compilation of innovative projects that are going to help restore groundwater levels and increase the water supply reliability in the Sacramento region. Okay, so for the presentation overview, so I'm going to go over the background, who Sacramento Area Sewer District is, the EcoWater Resource Recovery Facility. That's our wastewater treatment plant, as it used to be called. Nowadays, I think it's typical in the industry that wastewater treatment plants are now being called resource recovery facilities to recognize that they do have a stream of what used to be called waste, but now has nutrients and value that can be extracted and used for various purposes. I'm going to go over the HarvestWater project. So that was a large upgrade of our treatment plant that was the precursor to being able to make HarvestWater even possible. And then I'll jump into HarvestWater and talk about the two major components of the HarvestWater. We have two separate kind of programs running at the same time. We have the administrative side, which has been responsible for the CEQA, the permitting, the grant funding, monitoring, compliance, development of the eco plan, stakeholder outreach and agreements, coordination, and any of the other kind of non-capital administrative functions. And then we have the capital program, which I'll kind of run through, which is basically the planning, design, construction, and commissioning of the capital improvements that are required to meet the needs of HarvestWater. So for some background, Sacramento Area Sewer District. So formed in 1973, and the reason for that was post-World War II, rapid growth in the region had wastewater treatments popping up all along the Sacramento and the American rivers. And with water quality concerns being an issue in the 70s, the city, the county, city of Folsom got together and formed the Sacramento Regional County Sanitation District, SRCSD. And the goal was to regionalize the wastewater treatment in the region. So at that time, we did receive a significant amount of federal and grant funding, built a wastewater treatment plant down in Elk Grove, which was kind of the natural low point of our entire region, and then built a network of pipes out and connected to all of these previous wastewater treatment plants so that we could bring all that wastewater to one point of treatment and compliance. So it came online in 1982. So it took about 10 years to build all of that, all those facilities. So the EcoWater Resource Recovery Facility. So what used to be called was the Sacramento Wastewater Treatment Plant. So it's again, started in 1982. It was a typical secondary plant. We had a high purity oxygen activated sludge process. They went through clarifiers and then chlorination and disinfection and sent out to the river. It's one of the largest plants. We're the largest inland discharger west of the Mississippi. There are larger plants. They discharge into the ocean, like down in LA. Our permitted capacity is 181 MGD, but our influent range goes from a low in the summertime to 80 to over 600 in the winter. So a lot of water gets into the pipes, and we have to be able to treat a large range. Interesting to note that our 181 permitted average has stayed the same for at least 10 years. Even with population growth, our flows, at least our base flows, have stayed largely the same or even decreased. And that's probably largely due to water conservation, high efficiency appliances and taps and whatnot. And so the amount of water we have is going to play into HarvestWater as we talk about some other items here. So then what happened in 2010, we received a new discharge permit from the state. it had a series of very stringent requirements that required significant upgrades to the plant. So this picture here shows all the different different projects, discrete projects. There was 22 in total. I'm gonna just highlight the ones that made the biggest difference in our effluent quality. BNR, biological nutrient removal. This was primarily to remove ammonia, which previously we didn't have any way of removing, and our new permit required that. The tertiary treatment facilities, that's the granular media filters. So we've got anthracite and sand that brings down the NTUs. And then flow equalization, we've always had, and this is not typical of all treatment plants, but since we've had space, we've always had very large equalization basins. And part of this, project was to deepen them, line them all. Previously, they weren't all lined. Some of them were just dirt. They were only used in emergency cases, maybe in the winter when we had too much flow we couldn't treat, or we had process upset problems and things like that. So we kind of modernized our overflow basins, and so now we can use those for shutdowns when maintenance are needed around the plant, or just equalization of flows to make the process, more efficient. And then lastly, just a note here. So this area says soil stockpile. So when we built all these facilities, we generated over 1 million cubic yards of dirt, and we chose at the time for cost-saving reasons to just stockpile that soil on site. And so we had an area designated on site. So again, we're lucky to have space to do this. And so by the time we had that stockpile done, it was a very small mountain that had to be 30 feet tall, multi-acres. And so that was what's happened since then, though, is we have been able to, turns out lots of people need dirt. SAFECA needs dirt. They need dirt down here at the rail yards. And so we've been able to negotiate with folks for a very attractive rate, I think of $1 or less, to come pick up dirt and use it. Because if anybody's worked in dirt work, the money is not in the dirt itself, it's getting it to where it needs to go. So, and so nowadays we've actually been able to reduce that stockpile down to maybe 80% of where it was. And so over time, we expect we'll be able to continue sending that dirt off to use in the region for various projects, flood enhancement and whatnot. So, okay. So we are currently, this is shows what the treatment train looked like before and after. And so what's interesting here is that we are now currently the second largest tertiary treatment plant in the U.S. And does anybody know who the biggest one in the U.S. is?
Blue Plains?
Yes. Yeah, so Blue Plains is it's gigantic. Their average is 300 MGD compared to our 135, and their peak is over 1 billion MGD compared to our 600. So we probably number 2, but it's by a ways off of how big the DC plant is. So at any rate, so you can see before we had your basic secondary plant. With EcoWater, we reused as much as we could. Our preliminary treatment stayed the same, bar screens, things like that. The grit removal, scum removal, that all stayed the same. What we inserted was the air-activated process. That's the biological nutrient removal. Secondary sedimentation tanks, those all stayed. We were able to reuse those. They needed some enhancements to be able to work with the new process, but the basic infrastructure was able to reuse. We have a whole new filtration with battery of granular media filters. And then we had to go to a new enhanced disinfection, which was basically a contact basin that allowed for longer contact times to meet the requirements of Title 22. Previously, we didn't have enough contact time. And then we did some other safety upgrades during that time too. Prior to this, we were using gaseous chlorine to disinfect. It came in on rail cars, and while very cost effective, it also carries a significant risk profile in terms of safety. So we made the decision to switch over to hypochlorite. And so now we no longer have rail cars of chlorine, coming in and out of the plant, which I think makes us and a lot of people around, sleep a little bit better at night, knowing that we've avoided the potential problem with a leak from a rail car of chlorine. Okay, so this is a graph of what happened with our ammonia. So ammonia was one of the first items that was of concern in our permit, and so we didn't have a way of removing ammonia from our wastewater prior to the EcoWater project. What we did do during the time is a lot of the ammonia is locked up in our sludge, and what we were able to do was keep our sludge and the decant off of the sludge, keep it on site. And so what that did was keep the ammonia loaded in our basins, in our sludge basins. So one of the first projects to come online was nitrifying side stream treatment. So that was a series of bioreactors that was able to take that ammonia-rich sludge and start producing a nitrate end product that we're able to use around the plant for odor control purposes. And then eventually we got the BNR working, and you can see that our ammonia started out quite high, and now we're down to very low levels, well within the range of the Title 22 requirements. Okay, turbidity. So again, turbidity, obviously we didn't have filtration before, so turbidity was always running somewhere in the 5+ NTUs. After putting everything in operation, really the filtration is what drove this. So now we're currently running down below 2 NTU, which again puts us fully in compliance with Title 22 for unrestricted recycled water use. So that includes the irrigation of food crops. So that sets the stage for harvest water. So harvest water, and I'll just start here with, you can see there's the pump station, and you can see there's the granular media filters. So the water is coming into the filters. It hits that large contact basin where the water makes its way back and forth through the basin. And then we're tapping into that at the end of that zigzag line, and it either goes out to the river, or we're going to pull it out of the side into the harvest water pump station and send it down the transmission line to the South County or the harvest water system. So harvest water recycling, water recycling has long been in a goal of SacEWRI. So back in 2007, we published a recycling water opportunity study, and during that time, one of the ways that we saw that we could potentially use our water is if we could provide ag water to areas south of us, because we don't have a lot of urban areas right around us. Oops, sorry. We do already provide recycled water to the urban areas directly next to our plant. The medians and parks are currently using the recycled water, but harvest water was an opportunity to increase that significantly. So and I'll go into more detail, but the harvest water produces a multitude of benefits: the groundwater restoration, the ecosystem improvements, climate resiliency, etc. And we'll go into those in some future slides. So for funding, again, I'll go into those into a bit more detail, but the funding aspect, we've got $290 million from the state through the WSIP program, and we received 30 million from the Bureau of Reclamation water reuse program. So, and really the securing of this funding is really what got this program off the ground. Without it, it would make the economic viability of it very difficult to pencil out. So, in lieu recycled water, recharge of the groundwater. So this is a nice graph that shows, the modeling that we've done has showed that we're able to increase the groundwater by up to 370,000 acre-feet. That's about a third of the capacity of Folsom Lake, to give you a sense of scale. And then we're also going to be able to bring that groundwater up to within 25 feet. Actually, I'll get another slide, but we'll be able to bring that water up to a level where it's going to start providing benefits to the ecosystem. So there's a lot of benefits of just having the groundwater there for use, especially in years that we might need it. But there's also the benefit to the ecosystem of having that water coming back to the surface to provide those benefits. So here's some of the modeling that was done, and you can see the green. So all the green areas are the percentage of time that the groundwater is within 25 feet of the surface. So with the project and without the project. And so you can see with the project, we've got groundwater meeting this 25 feet from the ground surface requirement. And so when we're able to do that, we're able to get ecosystem improvements like trees like cottonwoods, willows, and even cattails all benefit from having groundwater closer to the surface. So yeah, so that's the. Here is one more that just kind of shows the overall benefits. So the ecosystem improvements actually go beyond our recycled water delivery area. So I know it's a little bit hard to see on this. You can, the white line around the outside, that's the extent of the eco-plan benefits. And then much smaller inside of that is the actual recycled water delivery area. And so you can see all these different riparian, vernal pool, and wetland areas all through the region that are benefiting from bringing up that groundwater, and as well as wintertime applications, which we'll talk about a little bit in later slides. So funding. So the 2014 Water Storage Investment Program, WSIP we call it, provided $2.7 billion for water storage projects throughout the state. The funding was tied to the public benefits and the Delta ecosystem. So the money wasn't free necessarily. We had to monetize and show benefit to the public and the ecosystem, and we'll go through those in a little bit more detail. So we submitted application in 2017, and we finalized the grant and the public benefits contracts here just recently, 2023. Okay. So these are some of the basis of our public benefits contracts with the state and California Fish and Wildlife. So crane habitat will be added by partnership with farmers to saturate their fields or flood them in the wintertime to increase foraging habitat. So we'll get an increase over time, especially if we apply wintertime water to fields. So that'll provide more habitat. So that's got a value of 60 million. Vernal pools will be added through easements, MOUs with landowners, and establishing various conservation areas. This can include planting appropriate vegetation and monitoring to encourage the development of those areas. Then we have the Consumnes River. So because the groundwater is coming back up, the Consumnes River flows are expected to improve because right now with the groundwater low, a portion of the Consumnes is just flowing down into the groundwater. So when we bring the groundwater up, we're expecting that we're going to get the Consumnes to have more flow, and that's going to have benefits to the salmon runs as well as any of the other aquatic life in the delta. And then finally, there's salinity. So the salinity in the delta will be reduced because the diversion of our wastewater will be sending it, instead of our effluent going into the river, it'll be going into the harvest water system. So that basically will end up lowering the salt load to the Sacramento River, which is predicted to decrease the conductivity because the Sacramento River is currently on the impaired list for electrical conductivity. All right, administrative program progress. So APMO has been working on harvest water for quite some time. In 2016, they brought on consultants Woodard and Curran, who've been helping with various items related to engineering, groundwater monitoring, Title 22 compliance, things like that. We also partnered with the Freshwater Trust. Freshwater Trust is a conservation group whose primary mission is to preserve and restore freshwater ecosystems throughout the western U.S. And they're taking the lead on the ecosystem development as well as outreach to landowners and farmers. So environmental documentation, we did SEQA and permitting. One interesting note, and if you're in project delivery at all, the way you typically will handle your permitting is you fully design your project, and once you know what the scope is, you submit those to go get your environmental permits. We had to do this backwards. We had to get our permits first because we needed to get the public benefits contract awarded. So we really had to guess on what the facilities would look like in terms of permits from the Corps of Engineers, the California Fish and Wildlife. And so we did things a little bit backwards. And so what that has put us in the situation where as the design laid itself out, we had to go back for various permit amendments with the agencies, and that process is still going right now. So just one of the kind of the challenges of the project. So petition for wastewater discharge by the state. So one of the first things we had to do was go to the regional board and get approval to not put our effluent into the river and instead send it to harvest water because there are, it's a significant amount of flow. Again, that's that 50,000 acre-feet per year turns out to be about an average of 70 MGD, which is a lot of flow. And so removing that from the river can fundamentally change the characteristics of the river. We think it's for the better, but it also reduces the volume for downstream uses as well. So we had to go to the state to get approval to do that. So that was approved, and just one piece that helped us move this project forward. So grant funding progress. Again, like I said, we have received our award of 291.8. We've actually started submitting for reimbursement of some of those items. We also received the $30 million from the federal United States Bureau of Reclamation. One issue that caused on the capital side is federal money comes with Buy American, Build America requirements, BABA. So that has been a challenge in some parts of the capital program. So for those that aren't familiar with BABA, that Buy America, Build America from the federal requirements. It basically means that your materials, your manufactured goods, pretty much everything that's being provided on the project has to be made in America. That can be a challenge. Waivers can be had in certain circumstances, but it can be a challenge, especially when it comes to electrical components, because not everything that we use in these type of projects is necessarily made in the U.S., especially pumps and motors and switchgear and things like that. So that's been a challenge, but we're working through it. So we've also been able to enter into some cost share agreements to help with the burden of the cost. Elk Grove, SEPA, that is South area or Southeast Policy Area. We're going to go ahead and provide them some water. They're right next to our pipeline as we're heading down to and get to our primary use, which is the ag users. SCWA, that's Sacramento County Water Agency. We're also providing them some water. So between the two of them, we're gonna be able to recoup about $14 million, at least the cost of the transmission line to get it that far. They don't get any benefit from the rest of the system. So they're paying their portion of the pump station and the line that gets it at least there to the point of where they're taking the water. And then finally, SACDOT, we were able to secure about $5 million from Sacramento Department of Transportation. And the reason is, and I'll go through it in a little bit more detail, is the rural roads are not built to current standards. A lot of them are in bad shape, and when you construct on them, they generally don't hold up very good. So we were able to get some money to help us. We weren't able to build new roads everywhere like we'd like to, but we were able to come up with some creative strategies to at least leave the roads better than when before we showed up. Okay, so the capital program. So we've got a total of 41 miles of pipe. So we've broken up the project into the pump station, the Elk Grove transmission main. You can see in red, it comes down through the city of Elk Grove. The only connections off of that are to Elk Grove for a very small amount of maybe 5 MGD. And then we've got a couple different other packages. We've got the Franklin Messenger pipelines, we've got the West pipelines, the Central pipelines, and then finally we have the on-farm connections. And so that's all the appurtenances that have to be built on the farmer's property to allow us to deliver, control, monitor, and count the water. So let's run through those real quick. So Harvest Water Pump Station, 105 MGD capacity, 7 total pumps, all the various control systems that would go with that. It's already started construction, and it's going to be completed, we're estimating, about 2027. So the interesting thing about the pump station is that it has 105 MGD capacity, and that's based on the demand that we've calculated from the potential growers. And the interesting thing here is 105 is the most that we could provide with the amount of effluent that we are creating. We're limited in the summertime. That's when when the farmers are going to be irrigating. It's also when we have the lowest effluent that we're treating through our process. So the actual amount of demand that we've calculated from the farmers that want to connect actually far exceeds the amount of capacity that we can provide. So, and I'll talk about that in a little bit. So we have a challenge in that we have to manage our ability to deliver with the demands, and sometimes they're not going to be meeting each other. So again, the Elk Grove transmission main, we broke it into 2 segments for some reasons that are probably not terribly interesting. It had to do with permitting. So we wanted to get this project going as fast as we could. we ran into some permitting problems on one segment, so we broke it apart and got the segment 2 project going right now because it's complicated. If anybody's been down Franklin Boulevard in the city of Elk Grove, we're putting this 66-inch pipe right down one of the lanes. It's difficult. There's a lot of utilities. Traffic control is going to be a challenge, and just general public disruption is going to be something that we're going to be working with for a couple years. Again, so you could see Elk Grove transmission main. We've got shopping centers, we've got an elementary school, we've got a golf course. So we've got a lot of areas where we're going to be, closing down lanes, installing, just making a mess of the place for, months at a time. So it's going to be a challenge. So the Franklin Essinger pipelines, this project was the first one to get out into construction. It's actively working right now. It's probably the first portion of the transmission line that gets the water past the city of Elk Grove and into our service area. So it starts at 66 and then it branches down all the way to 16-inch as it provides to the farmers. So I'm a construction guy. I like construction pictures. So if anybody's familiar with the area south of Elk Grove, you can see in the picture on the left, you can see that Quonset hut in the background. That's Kingskate. That's a skating rink that's in a Quonset hut. I think it dates back at least 50 years, maybe at least 40. It might be 50 years old. Been there forever. So you can see we've got the road closed down, so we're not popular in that area right now. The area on the right, so that is Bruceville Road as you get south of the city of Elk Grove. And this is just a nice picture because it shows what the construction looks like. You've got, an orchard on one side, you've got ag land on the other. And again, we've got the whole road closed off because the road just isn't large enough or wide enough to support keeping traffic open and getting this pipe installed. So detours and public notice is a big deal for us, and it's a challenge. So the West Pipeline project continues the distribution all the way down to Twin Cities. Again, this project is in construction. It's going to be done prior to the pump station 2025. Again, I have some pictures here. So this is kind of interesting. So the left-hand side is one of the outlets for the connection to one of the farmers. And then on the right side, that's I-5 at Twin Cities, I think. So our pipeline goes under I-5, under the underpass, and provides water to users on the other side. An interesting challenge here is that one of our construction crews managed, because when they were digging underneath I-5, they managed to bring the bucket straight up and punch a hole in the bottom of I-5, and so I haven't heard what they've done with that, but they're working on a repair of that. It didn't cause any problems where they had to close down I-5, but the dangers of letting contractors loose. And then finally, the last of the construction projects, at least the pipeline projects, is the Central South. And so this is essentially fills in the rest of the area. It's mostly small pipe, 12 through 26. That would mostly be HDPE. That project is just now getting going. I don't actually have any pictures of it because they don't have any in the ground yet. So, and then finally, on-farm connections. So this is the projects that are going to deliver the water to the farmers. So you can see we've got a number of appurtenances there, from flow meters to backflow preventers to on-site communication with PLCs that connect back with pressure transducers to the pump station, so that the pump station knows when to deliver and when to not. And then we can also grab the information for billing purposes. So you can see there's 130. So all those little white name tags, those are all connections. And then the shaded area is the area that's being irrigated. So you can see that we've really been able to get participation with almost the entire service area, minus maybe some big areas like that big square there is the executive airport, or is that an airport? It's an airport. Franklin, yeah, there you go. Franklin Field, there, got that wrong. Franklin Field. So yeah, obviously we're not providing any water there. It's an airport. So again, this project is lagging all the rest because you really can't build these final end piece until you've got some pipelines in there to connect to. So they're currently finishing design, and pending our the amount of grower agreements that come in, which we're working on right now. We might break this up into a couple different construction packages, but right now we're looking at sending the first package out to construction by the end of the year, and potentially another package maybe some months after that, with the overall goal of getting all the construction done somewhere around 2027. So again, some of the challenges with the capital side of this, trenchless crossings. So again, to be in compliance with our environmental permitting, we really had to tunnel underneath bodies of water, vernal pools, any environmentally sensitive areas. Our default was to go with trenchless techniques to get that water through there. Turns out the railroad tracks we kind of end up having to zigzag back and forth across the railroad tracks a couple times. So every time you go through the road, underneath the railroad tracks, you got to tunnel and put in a casing and those items. And then some of the major intersections in Elk Grove, we also tunneled just because of the impacts on traffic. So tunneling can be anything on the larger side. It's usually micro tunneling due to the depth and groundwater. And then as we get to smaller sizes, 36 and below, we went with other techniques like open face, rotary wheel, auger boring, or even pipe ramming. So environmental constraints. And again, this is just for construction. And this is kind of when we laid out all the requirements from the South County Habitat Conservation Plan, and the various other resource agencies. The roadside ditches can have special status species in them. The ag fields can have special status species in them. And after we got it all mapped and we got it all laid out and we got the requirements of the open windows of when you can and when you can't do construction, we came to the conclusion that you can't build anything, anywhere, anytime. And so that's where our permitting team worked with our design engineers, worked with the resource agencies, came up with some solutions that had versions of windows, exclusion fencing. Certain times of the year, if we put up exclusion fencing to keep the special status species in their active periods away from construction, we're able to construct during those windows. So we were able to really open up those windows and able to get that problem solved. So what that means is we've got biologists from our permitting team that are following around the construction all the time. They're watching the construction. They're doing pre-construction surveys for any special status species to ensure that there's nothing there before the construction starts. Providing environmental awareness training to all the workers. Any construction worker that comes on site has to go through the environmental training. So again, this is the environmental component and the environmental focus of this overall program has extended all the way into the construction process. So again, rural roads, very narrow. This is just kind of a picture of what it sort of looks like. The challenge being that we have to put in, sometimes we have to put in some culverts to get access where we're gonna be putting the on-farm connection. So I mentioned it before, but pavement restoration. This picture is very typical of what the roads out there look like. So you can imagine what it looks like after you get dump trucks and front end loaders and excavators. Our contractors put down steel plates, timbers, whatever they can to try to save it, but it's been very, very difficult. And so this is part of the reason why we worked with Sacramento Department of Transportation to come up with some ways to not build a brand new section, because brand new roads would have been outside of the reach of what any of us were able to provide in terms of funding. So we did come up with some ideas to replace the existing pavement. We're doing some full depth reclamation in some places, and in some places we're just doing kind of an enhancement of what the existing pavement was. But the overall goal has been to leave the roads in a better condition than when we got there. So I think the end product is gonna be satisfactory to everybody. So now the budgets. So the overall program is pegged at $597 million. So we currently have a funding gap of 275. So 379 of that is the infrastructure that we're building on the capital side. The ecological program is 79 million. That has to do with the groundwater monitoring, the purchasing of land easements, things like that. Other program costs, that's basically soft costs. We're still carrying a fairly hefty contingency because we're still early on in the program, so we don't know what's gonna go on there. So again, we've received $320 million of grant funding, so it's a little bit over half. And so really, without that money, the funding probably wouldn't have made sense for this project. So we're grateful to the state and excited that we're able to make this project a reality. So some of the operational challenges. So like I said before, our summer flows at the EcoWater Resource Recovery Facility are about 70 MGD. At times, the pump station has a capacity of 105 MGD. The amount of farmers, if they were to all take their water at the same time, greatly exceeds 105 MGD. So the problem we're working on is kind of a water ordering system, where we're going to have people ask for water for a certain time over a certain period of time, and then we're building a enterprise management system that's going to look at that demand, that's going to try to forecast, it's going to have some smart capability in it, and essentially be able to manage these water deliveries requests in conjunction with the overall system at our plant, with the effluent that's being created at the time. That is the end of my presentation.